Progress is impossible without change, and those who cannot change their minds cannot change anything. Hi all, Dr. Clark here again, and this time we're going to talk about the hydrosphere. So we talked about the atmosphere and the different layers of atmosphere. We talked about the geosphere and the different components to the abiotic portion of our planet, abiotic except for water. So non-living portions of our planet is geosphere except for water. Water is in its own sphere, which we call the hydrosphere. And here in this picture, you can actually see the three different modes of water, the three different ways water can be represented on our planet. You can see ice or solid, liquid form, and vapor form. And so we're going to talk a little bit about that. We're going to talk about the water cycle again. So I'm going to hit on it again. And then you guys are going to watch a video about water in the world today. It's called Blue Gold. And you're going to watch that video and kind of get an idea of what's going on in the world today around water issues. And maybe you know, maybe you don't. So we're going to look into that in a little bit. All right, so let's progress with hydrosphere. So the hydrosphere, we've already talked quite a bit about water, but the hydrosphere is the combined mass of all water on the planet. So every bit of water molecules that occur on the planet make up the hydrosphere. What state the water is in really makes no difference. It's still part of the hydrosphere, so it can be in ice, liquid, or vapor. It also doesn't matter really what's mixed with that water. That's still part of the hydrosphere. So it can be ocean water, it can be fresh water, it can be groundwater, etc. So here you can see actually the formation of what is called salt water sometimes, or ocean water. You have water molecules. Remember, we talked about water molecules before. They're a polar molecule. So it means that they have a charge on one side that's different than the charge on the other side. So the molecule has opposite charges. So it's positive over here where the hydrogens rest. And it's negative over here on the oxygen side. Well, here's a different molecule. This is called sodium chloride, or sodium bound to a chlorine molecule to form sodium chloride. This kind of bond, because sodium is a positive charge and chlorine is chlorine is a negative charge, it forms sodium chloride through an ionic bond. Okay, so an ionic bond is the attraction of positive molecules to negative molecules and vice versa. So sodium chloride, when it forms a crystalline structure, or a crystal-like structure. And this is table salt, okay? Or salt is what lay people would call it, is salt. And that crystalline form often happens when you're dealing with ionic bonds. Anyhow, when salt is mixed with water, the molecule, the ionization bond, or the ionized bond, breaks and the molecules disassociate with each other. And they associate with water molecules. The chlorine molecule is going to associate with water molecules in one way. Okay? The negative is going to be attracted to the positive of water molecules. So this is what we call a hydrated chloride ion. And the sodium ion, having a positive charge, is going to be associated with the oxygen side of water molecules, and that's what we call a hydrated sodium ion. And so this is how you make salt water. Salt is, added to water in many different ways, either because it occurs on the surface, okay, etc., due to runoff. Okay, there's lots of salts in the ocean. Okay, so when they encounter each other, the salt encounters the water. It's dissolved because water can dissolve salt and turn it from this ionic bond into non-bond and disassociate the two molecules, the sodium and the chloride molecules. Okay? So the reason why I bring that up is we look at salt water and we look at water on the planet, and water on the planet there's quite a bit of water on the planet. 1,380 approximately, okay, give or take, million cubic kilometers of water on Earth. The issue that we often have, though, is 97.5% to 98% is salt water. It's this combination of sodium and chloride with water. 71% of their surface is the ocean, okay? But most terrestrial organisms cannot utilize salt water. So that's where this needs to come into context. If 97.5% of your water, okay, is salt water, that's not leaving very much left when you start associating that with this. So you got 2.5 that's fresh water, but of the 2.5% that's fresh water, 68.9% is ice or permanent snow. It leaves us about 1% or so of material that we would consider fresh water that's available for us to grow crops, to drink, to make products from, etc. So there's a big push. There's this idea that can we desalt or desalinate water? Can we take some of this 97.5%, can we take that and get it into fresh water? Can we take it in an easy form, remove the salts, and get some fresh water? Because our fresh water, we haven't been doing a very good job with it. We've polluted it a lot, and we've done a very poor job at maintaining good freshwater sources. So, there's one camp that would say, hey, we should just go desalination and we should remove salts, get our fresh water, and we should utilize that. And there's another camp that says, well, why don't we just clean up the pollution that we put in our water sources to begin with? We would have plenty of fresh water if we weren't polluting it. Often the problem with that cleaning up the pollution is cleaning the pollution up in many instances is going to be more expensive and harder than finding a way to remove the salts. Right, so that's kind of where we're at worldwide, and you're going to watch a video called Blue Gold that talks a little bit about this, but worldwide we're kind of at this breaking point. We need to find out which method, or maybe we're going to do both methods, but we need to find out how much energy are we going to expend to remove salt from water so we can make it fresh water, or remove pollutants like oils and other things, steroids and hormones and other things that could be toxic to humans. Remove those from water where are we at? Which one are we going to do? Are we going to do both? But something needs to be done. There's a lot of great examples, or I don't actually want to put great in front of it. There's a lot of poor examples of things that we've done with water sources where people have been hurt by that decision or non-decision, like Flint, Michigan, and the situation that's occurred there. There's been situations that have occurred in other states where water rights were taken away, and people have given rights to other industries, maybe fracking industries, etc., that have destroyed water columns, destroyed water resources, underground water material, and that is an issue because of this piece right here. We only have about, this says 2.5%, but remember about 70% is ice and permanent snow. So we only have about 1% of the world is fresh water that we can consume. And so we need to treat it like there's only 1% that we can consume. All right, so let's look at the water cycle, and we'll come back and look at man's role in disrupting the water cycle later. But I just wanted to make sure that everyone is on the same page when I'm talking about the water cycle. What are the different terms for the water cycle, and kind of where's the water coming from, where's it going, etc. We've already stated this before. Water is not created nor destroyed. All the water that occurs on the planet today occurred 4.6 billion years ago. Water evaporates and turns into vapor. It can do that through evaporation off of the ocean, evaporation off of lakes, rivers. Okay, if it's evaporating off of a solid form of water, like snow or ice, it's called sublimation. Okay, so sublimation is when water turns to vapor from the solid state. Okay. If it's being released from an organism like a plant, it's called transpiration. Okay. But those are the ways at which water gets into the vapor form. Okay. That vapor form will eventually condense, okay, and drop out in the form of precipitation. Precipitation, as we talked about before, could come in the way of snow, rain, sleet, hail, whatever you want to call it. Okay, it can come in that form. Now, that condensation is the result of cohesion, like I stated before. The attraction of water molecules to other water molecules will make it so they get close to each other, they form, they become dense. The density increases. The density is too much for the clouds to hold it, and the water falls back to the planet. Gravity takes the water back to the planet. So, vapor, liquid, okay, and then that liquid can turn solid, or it can be deposited as a solid to begin with through the freezing process. It can be dumped in as snow, it can be formed as ice, etc., but it would come in a solid form under temperature consideration. Okay, so again, water cycle. There's lots of places on the water cycle where we can disrupt it, and lots of places where we do disrupt it. And we'll come back and we'll look at those places and that disruption as we progress with pollution and things like that. Okay, before we dive into the video I want you to watch, let's talk a little bit about Bernard Palissy. Bernard Palissy, this is a self-portrait of Bernard Palissy. He's actually a really famous pottery maker, and so he is a really famous artist, but he liked to dabble in science, and he was based on all records that we can tell, he was the very first person to describe the water cycle, and was one of the first people to talk about the scientific method in describing or refuting previous thought processes. Okay, and so Bernard Palissy wrote this: if things conceived in the mind could be executed. He was talking about alchemy. We already talked about alchemy as a pseudoscience. Okay. Alchemists would do great things. So in other words, if they could actually do what they say they can do in their mind, or think they can do, they could do great things. They could change tin into gold or lead into gold, etc. We must confess that practice is the source of theory. By experiment, I prove in several places that the theory of several philosophers is false, even of the most renowned and most ancient. So in other words, he was using the scientific method to refute a lot of philosophers' claims around not just the water cycle, but other things that he was looking at in nature. He wasn't going to accept these ancient ideas and philosophies of how things work, including how water came to the planet, i.e., God makes it rain. He wasn't going to accept that. He decided to test scientific processes using the scientific method, or his own form of the scientific method, to test out, what's the water cycle like? Where does water come in? What's the different states, going to vapor, going to solid, going to liquid, etc. Okay, so I just wanted to give him credit for describing the water cycle, and a little bit about his role as a scientist, even though he was really an artist by training. Okay, so next you're going to watch Blue Gold, and we're going to come back and chat about the final sphere, and that is the biosphere. Okay? And so we'll obviously come back and talk a lot more about water, but we also are going to introduce that biosphere and the role that the biosphere plays in interacting with all the other spheres, the geosphere, the atmosphere, and the hydrosphere. Till next time.